Hey there! In this video, I'll share with you an effective method for explaining the trends of the elements in Group 7 of the periodic table. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let us begin from a place of similarity in the trends of the elements in Group 7 with the trends of the elements in Groups 1 and 2, and that is atomic radius. For us to understand this trend, we need to go back to atomic structure. The atomic number for fluorine is 9, and that of chlorine is 17. We'll focus on these two elements in Group 7. So, the atomic number tells us the number of protons in the nucleus of these atoms, but it also tells us the number of electrons because atoms have no overall charge, and if the protons are positively charged and electrons are negatively charged, then there are equal amounts of protons and electrons in these atoms. So there are 9 electrons and 17 electrons in fluorine and chlorine respectively. How are these electrons arranged on the shells as they orbit the nucleus? For that, we need to understand a very simple rule that the first shell can hold a maximum of 2 electrons, the second and third shells can hold 8. Following that rule, we can write the electron configuration for fluorine as 2, 7, and for chlorine as 2, 8, 7. We see here the development of the first trend, and that is within the group, the elements will have the same number of valence electrons. Valence refers to the outermost or the last shell of these atoms. Let's draw the diagram of a simple model of the atoms of fluorine and chlorine. So the first shell with 2 electrons for fluorine is drawn like that, and the second shell, of course given by our third circle here, has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Let's now draw a diagram for chlorine, and the first shell given by our second circle, our second shell by our third circle, and the last shell or the valence shell with our fourth circle. How are the electrons arranged? 2 on the first shell, 1, 2, 8 on the second shell, 1, 2, 3, 4, 5, 6, 7, 8, and 7 on the valence shell. 1, 2, 3, 4, 5, 6, 7. As we go down the group with each successive element, there is an addition of a new full inner shell. That means the attractive pull of the nucleus of these atoms for the valence electrons gets weaker because there is interference in the attractive pull. As a result, we have greater shielding effects in chlorine than in fluorine. So with this weakened attraction between the nucleus and the valence electrons, we have an increase in atomic radius. Atomic radius increases going down the group because of the increase in shielding effect. This also affects other trends, as we will see, and let us begin with the trend in the formation of ions. Now, for nonmetals to become stable, they need a full valence shell. The elements in group 7 have 7 valence electrons and therefore need 1 more electron to obtain a stable electron configuration. So, since they need to attract incoming electrons, they develop something known as electron affinity, or the love for electrons, which we can describe as the electronegativity. Fluorine has the greatest electronegativity because it has the least shielding effect. So, if fluorine has the greatest electronegativity, it means that when reacting with other atoms in chemical bonds, fluorine will be more reactive than chlorine. And the trend is, as we go down group 7, reactivity decreases. To make this point even further, let us look at the reaction between chlorine and potassium bromide. Cl2 gas plus potassium bromide, that's aqueous, going to form potassium chloride, and this is a single displacement reaction, and bromine. And let's just write liquid for the state symbol. To balance this equation, we need to put a coefficient of 2 in front of the potassium bromide as well as in front of the potassium chloride. Here we see that chlorine is displacing bromine from its compound. In displacement reactions, the elements above in group 7 will be able to displace elements below them because they are more reactive. Also, they are more electronegative. Remember that when chlorine is going to be transformed to chloride ions, it needs to accept an electron, that is 1 electron per atom. When substances accept electrons, they undergo reduction. The opposite is true for the bromide ions, which are giving back their electrons that they obtained to become ions as they return to the atomic state. So since they are losing electrons, they are undergoing oxidation. Since chlorine is causing bromine to undergo oxidation, then chlorine is operating as an oxidizing agent. So fluorine has the least shielding effect, the highest electronegativity. It is also the most reactive element in group 7, and it has the highest oxidizing strength. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to refer to concepts such as shielding effect and the attractive pull between the nucleus of the atoms and the incoming electron to turn halogens into halides, to explain why there is an increase in atomic radius going down the group, but there is a decrease in electronegativity, reactivity, and oxidizing power. Good luck on your exams, and I'll see you next time.